Hi. So today in class you're going to be doing a lab on stellar evolution. And the instructions are all on the handout, but I want to take a few minutes and go over them with you just so I can get a key important parts. So first off, you're going to be getting a baggie full of cards like this. The cards, you wouldn't think it are, but actually kind of an expensive thing because they're part of a kit. So if you lose any of the pieces, you make the kit basically worthless. So it's really important that you get all of the cards back in the Ziploc baggie that they come in. So you'll notice when you get your cards that there are different kinds of cards. So first off, there are some cards that are high mass stars and some that are low mass stars. The very first thing you want to do is separate your decks. We're only going to work with low mass stars at a time and then high mass stars at a time. So separate them and put them in two different piles. And then what you'll see is that within the cards there are different types. There's three different bottoms. So there's the properties cards. There are the characteristics cards, and which are C's, and then there are the object cards. So your task will be to make sets of 3. Each of the properties and the objects cards are numbered on top. Obviously these two don't go together, but you will find 2 that do. And when you do, you will pair them up. Your task then is to find the characteristics card that goes with that. Okay, so you're going to start by pairing up all the 1s for low mass star that are P's with the 1s for low mass stars that are O, because those we already know. Your next step is to look at the characteristics cards. And you're going to scan through and see which one of the characteristics cards matches up with the pair. And you'll do that for each of the 9 cards you have for each of the 2 sizes of stars. So, if I look at this first one, low mass star says, a portion of giant molecular cloud begins to collapse by gravitational attraction, perhaps triggered by a nearby supernova explosion. And then I just have a picture with the object's name. So, I know that I'm talking about a nebula, that's a giant molecular cloud. And so I want to look for characteristic cards that sound like they could be talking about a nebula. So, what I know from notes about the nebula is that nebula are cold and dark. At least the kind of nebula we're talking about that form stars. So I want to look through here. Years and stage might be somewhat helpful when we get to later stages because we know, of course, that generally the progression is that it speeds up. But I want to look for some of the other clues, like the others, the radius, the temperature. Now these 2 numbers with the L with a circle next to it and N with a circle next to it refer to the luminosity of our star, our sun, and the mass of our sun. So in this case, we're talking about the less than symbol, 0.1 luminosity of our sun. So we're talking about something that's very, very dim. Here we're talking about 0.5, the mass of our sun. So we're talking about something that's very small and half the mass of the sun. So this one, I expect it to be low luminosity. But half the mass of the sun, that seems a little bit sketchy for a giant molecular cloud. It talks about ejected material forms an envelope of gas. The central star is Earth size. That doesn't really sound like a cloud to me. So I'm going to eliminate that one. And if I look at this one, temperature of 3,000 to 4,000 Kelvin, well, that's pretty darn hot. So even before I look at the luminosity or the radius, by the way, R with a dot after it is the radius of our sun, even when I look at this doesn't quite add up because that's so hot for a giant molecular cloud that's going to form a star. So as I flip through here, I'm looking for things that seem to make sense. And I'm going to find this one where it talks about a temperature of 10 to 20 Kelvin. Now, 0 degrees Kelvin is absolute zero. That's about as cold as you can get. And almost everything else that we're talking about are in the thousands of degrees Kelvin. So this is mighty cold. It also talks about a very low luminosity. It's a collapsing gas and dust. The radius can be up to 3,000 light years. So this really does seem like it is in a cloud. The clue is it's got a cloud. So this tells me that this is most likely goes with number 1. And so I'm going to line it up next to this. And then I'm going to make room. I'm going to move and put my next 2 here. And I'm going to start scanning through these to see which of these matches my next stage, which is a protostar. You're going to do that for all 9 of the cards for low mass stars. So once you have taken all of the low mass star stages and found an O, a P, and a C card for all 9, then you're going to get it checked against the answer key. The ones that aren't right will be noted, and then you're going to keep trying until you get the right answer, the right lineup. It's really important then that all members of your group take a photograph, either with their Chromebook or your phone. And you want to make sure that in your photograph you can read the data on the card, specifically the C card. When you finish up and you're doing the lab practical, you're going to need that data, and you won't be able to take the deck home, and you certainly won't be able to take them home in the right order because you need to glue them down or something. So it's really important you get a nice clear picture. The next part is, once you've got all of the low mass stars, what you're going to do is you're going to plot them on the HR diagram. So you will take all of the temperature and luminosity readings and you'll connect them, remembering that some of them are going to be off the page, so you'll put them kind of over in the corner here. And so for the low mass stars, you're going to label them L1, L2, L3 that correspond to the numbers on the cards. And so you will plot them, and you should have, once again, all 9. And what you will do then is when you have L1, L2, and L3 in the appropriate place, you will connect them with a line. Once you've done all that for the low mass stars, then you'll switch piles and do it again for the high mass stars, making sure you do all the parts. So you line up the cards, get them checked, take a picture, and plot them on the HR diagram. This time you'll be using H1, H2, H3, etc. Before you leave, take a couple seconds and jumble up the cards so that the next group has to do a little bit of thinking, not just putting your cards out onto the desk. And make sure they all get back in a Ziploc so that they don't get lost for future use. There are 2 parts of the assessment. There's the paper copy, so I will be collecting the HR diagram. There's some questions on the back. I'd like you to do them. There's some reading involved with the books that are in the back of the lab area. Focus on the second part, which is the Canvas section. I will be skimming the questions, but they're really more to help you answer the Canvas section. So do them, make sure you understand them, but really focus on the Canvas questions. You're allowed to take them twice, and it is really important that you can read the numbers and the pictures you took so that you can answer those in the Canvas lab practical. As always, come see me if you need help. I'll be their resource after school, class, etc. Good luck.